Good morning and good afternoon, everyone. Welcome back to Beyond Compliance. My name is Aaron Bolshaw with Safety Chain Software. I'm the moderator of Beyond Compliance. And today we're talking quality and specifically the cost of it, good, bad, ugly, but mostly just getting a much better understanding of all of the components that goes into it. Beyond Compliance is a periodic industry update for process manufacturers. Our goal, simple, just bring you insights from around the market that shape the way you grow our businesses, deliver quality products to your customers, and safeguard our brands, all while improving yields and maximizing productivity. Two very key parts of that. So the webinar sponsors by Safety Chain Software, which is the #1 plant management platform trusted by over 1,500 manufacturing facilities to improve yield, maximize productivity, and ensure compliance. So we're scheduled for about an hour today. We figure we've got about 45 minutes of presentation. We'll get to some questions at the end. Before we jump in though, just make sure everyone understands everyone's on mute, but we do want to hear from you. Use the webinar console on your right there to submit questions throughout the presentation, and we'll save time toward the end to get to as many as we can. So, and the answer to everyone's favorite question, if you do want to get the slides and the recording from today, just ask us. You can just give us a little chat or a question. We'll make sure that we follow up with you. So, and with that, I'd like to introduce today's presenter. Dennis Devos is a professional engineer with a wide variety of technical and quality assurance management skills. He's a recognized expert in the application of ISO 9001 and other management system standards. He's a fellow, actually, of the American Society for Quality in recognition of his lifelong career in manufacturing and management system support. So that's very, very, very cool. And for the past 20 years, Dennis has been working with clients from a variety of sectors, such as automotive parts manufacturing, municipal water treatment, food and beverage packaging, box board, polyester films, and PET bottles. So very wide degree of process manufacturing background as well as discrete. And his practice areas include management systems, implementation, auditing, process improvement, lean workshops, a variety of training topics. And of note here, one of Dennis's lean transformations with an industrial chemical plant was actually featured at one of the ASQ World Conference on Quality Improvement. So very well recognized leader in this space, and we're really happy to have you on board to talk about the cost of quality. Welcome, Dennis.
All right, thank you. It's a pleasure to be here. I hope everybody can hear me. As Aaron said, my name is Dennis Devos, and here to talk to you this afternoon, or rather this morning, depending where you are, on the cost of quality.
I was going to say, I think a lot of folks on the line today, Dennis, probably measure the cost of quality to some degree, right? But I'm also going to guess they're not quite considering all the correct components. So why don't you get us started by giving us an overview of what we're going to go through today, and then just jump right in, okay?
Okay, thank you. I'll be talking about the cost of quality model. I'm sure a lot of you have seen it before, and that's what has piqued your interest in attending our webinar this morning. So we're going to talk about the model, but we're also going to talk about maybe some of the costs that traditional cost of quality and cost of poor quality models don't include, some of those opportunity costs, and then talk also about how failures and a high incidence of failure erode our production capacity. And all that really means is, when we're full and we can barely keep up with our customers' demands, the last thing we need to be doing is running, scrap or seconds or other things when we could be making, good products. We're going to be talking about how dangerous it is, especially when we have no capacity and we need every moment we have to make good product rather than non-conforming product. And then we'll talk about some tips for reducing the cost of quality. I have an example at the end that I'll show you from one of my clients and how you piece this thing together. And when we work with clients and generate a cost of quality model for them, invariably they're very shocked and very surprised when the true cost of poor quality emerges. So we're gonna take you through the approach that we use, and then we'll reserve our Q&A for the end. Okay, there we go. What is the cost of quality? So we found a definition in ISO 24765. If a definition comes from an ISO standard, it must be right. We can consider the cost of quality just simply as a method for determining the costs incurred to ensure quality. So there's two components, two halves, if you will, in a traditional cost of quality model. The total cost of your quality is the cost of your good quality on the right in green, right? Some investments that we make in preventing problems, some investments that we make in testing and inspection, right? So the investments in ensuring quality, making good quality the first time, and that would include sort of the cost of inspection. So we have the conformance cost of quality, if you will, appraisal costs and prevention costs. On the left, we have the costs of poor quality. So we have a cost associated with ensuring conformance, and then we have a cost associated with non-conformance. Internal failure costs, such as scrap and rework, and then external failure costs associated with a customer complaint, a product recall, heaven forbid, something that happens after we ship our product or service. So we're going to be talking about all four of these components of the total cost of quality. So the non-conformance costs, as we said, external failures after you've shipped a product, warranty, sorting, any type of customer complaint, any type of consumer complaint, things of that nature. Then there might be the failures that occur internal to your organization. They don't make it outside to your customer. Scrap, rework, low yields, whatever those might be. On the conformance side, we can think about the appraisals or inspections and tests, any routine inspection, testing, auditing. Those things go on the conformance side because they're meant to sort of assure quality. We think about prevention costs too, right? The HACCP activity that we use, where we think ahead, we predict, we anticipate failure, and we proactively put controls in place to prevent non-conformance. In the food and beverage world, it's HACCP. In the manufacturing world where I come from, it's failure modes and effects analysis, very much the same thing. We can invest in automation, we can invest in worker training and qualification. So any of those investments that we make to prevent failure, prevent non-conformance, go, let's say, on the conformance cost side of the ledger. Many of you have probably seen this before. There are some very obvious components, if you will, that we all measure when it comes to the cost of poor quality. In this case, we're talking about the cost of failure, the cost of poor quality, waste, rejects, rework, returns from customers, product recalls, heaven forbid. But I want us to think a little bit more expansively. And in this presentation, we'll talk a little bit more about those hidden costs that are maybe below the waterline. Right? Things like excessive overtime. If your plant is busy and you have to remake product, well, you're doing that on the weekend, and you're going to be charging your labor at time and a half. So those are factors that need to be considered. Think about the grief associated with problems that we need to solve. Paperwork, excess inventory. Very often, as a hedge against having an internal failure, we build safety stock. Right? Or because we have losses, we build more into each batch. If we have a problem and we're going to be late to our customer, we may have premium freight. Sometimes if we go to the customer for concession, we have to discount our product and say, this batch is maybe not quite perfect, but we'll give you some percent off as a customer allowance for them to take it. Complaints handling, dissatisfied customers. What's the cost of all of us, and all of us in a quality role, right? To some degree, we are either chargeable to the cost of conformance if we're maybe in a proactive engineering role, or if we're running around solving problems, we go on the non-conformance side of the ledger. So what's the cost of all of our salaries, all of the grief running around trying to chase this cost of poor quality? So part of my mission today is to encourage all of you to really start thinking about those hidden costs that are below the waterline. We're going to talk more about that as we go. More examples of the price, the cost of non-conformance, external failure costs, like we said, warranty, sorting. You probably have to remake an order. If you have to remake an order, what's the cost in time and grief to break into the schedule? If a customer complains and can't use the product that you provided to them, well, they need that product right away. More often than not, we have to break into our schedule to remake that product. We don't just put them at the back of the line and make them wait. Do we have to travel to see our customers or travel to the field? Any costs, any travel costs associated with trying to resolve a customer's complaint or a consumer's complaint, that belongs in the cost of poor quality, and we ought to capture that. It's hard to quantify, but think about the cost to us of customer grief, loss of reputation. I'm going to be talking about loss of reputation at the end of this presentation. Internal failure costs, garden variety, scrap, rework, repair, remake an order, breaking into the schedule to remake an order. I want us to remember that. That can be a big one. Maybe downtime for a quality issue. We may not always think about loss of efficiency or downtime or OEE as having kind of a cost of poor quality component. But if you suffer downtime because of a quality issue, or maybe your sanitation wasn't done right, I would put that definitely in a cost of poor quality. Taking a markdown to earn concessions, expediting raw materials. Again, a lot of these on this slide are obvious, some maybe are not. And again, I want us to think just that little bit more expansively about the true cost of our non-conformance. Conformance costs. Now, throughout this presentation, of course, we're going in both directions. We're talking about the cost of non-conformance and the cost of conformance. The model does include these conformance costs, although in recent years, the cost of quality model has changed somewhat to focus mostly just on the cost of non-conformance. But let's balance the cost of non-conformance against the investments we make in conformance. The investments we make to prevent adverse quality events, the design choices that we make. DFM stands for Design for Manufacturing. If we can make good design choices that are friendly to our manufacturing process, we're likely to have less errors, likely to have less cost of non-conformance. HACCP and FMEA, definitely prevention costs. It's an investment that we're making to prevent non-conformance. Error proofing, automation, training at all levels, our quality management systems, our safety management systems, all of these things are investments we make to prevent non-conformance. And auditing at all levels. These are costs, but they're investments that we make to assure quality and reduce the cost of non-conformance. Appraisal costs. Appraisal means inspection, basically, anything associated with product inspections, product testing, receiving inspection. The cost and maintenance of inspection and testing equipment can be considered a conformance cost and appraisal cost. Maintenance, calibration, labor and materials associated with these. So these are all costs to assure product quality and customer satisfaction. Now, the cost of poor quality, depending on the nature of the problem you have, can be very expensive, especially in the food industry, if one of our quality problems results in some sort of product recall. When the cost of non-conformance is very, very high, and we know what those costs are, that becomes an impetus or an inducement for us to invest more on the conformance side of the ledger. And all it takes is one batch, doesn't it? One bad batch is too many. And when it comes to food safety, we have to spend whatever it takes to fix the problem. And these get very expensive. In the industries that I work in, we sometimes get put on containment. And I work with some packaging suppliers, and I know that, let's say you supply packaging to the food industry, and you're sending some packaging to Kraft Foods or to Coca-Cola or some big food and beverage customer, and maybe the color isn't quite right. Well, what they might do is put you on containment or controlled shipping. There's a number of different names for it, where you are responsible to perform 100% inspection for the defect until you get the process back under control. If you discover that you can't get the process under control, that 100% inspection could last forever. And on the slide, I just have an example of what some of those costs can be. If you're subject to these types of penalties in your industry, if your customers impose these types of penalties, they get very steep, and they need to feature very, very prominently in your cost of quality model. This is the cost of quality curve. Now, if you think about it, if the cost of your failures or the cost of your non-conformance is low, right? If it does not cost very much to screw up, then you probably will not need to invest very much in automation and controls and conformance, right? If you have errors or you ship defective product and maybe that your customers aren't that concerned or it doesn't cost you very much, it would be more cost effective to just let those errors and mistakes go into the field and then pay to fix each one as they arise. On the other hand, when your cost of non-conformance in the field gets very high, there's more of an impetus to invest, right, on the conformance side of the ledger as insurance to prevent bad things from happening. So if you look on the left-hand side of the graph, it says poor quality. If you have poor quality on the far side, the appraisal and prevention cost curve is probably very low. Like I said, you're not spending very much on appraisal and prevention, but you may have a fairly high internal and external cost of failure. So if you move slowly across the curve, as your quality level improves on the x-axis, you may be spending more on appraisal and prevention cost. As you do that, we hope that your internal external failure cost curve comes down. And then eventually you see they cross in the middle. And at some point, you may be chasing diminishing returns. As you go to the far right-hand side where you have exceptional quality, you may have very, very low internal and external failure costs, but those appraisal and prevention costs have gone up. And so we look at where those two curves cross, and that becomes your optimal cost of quality. that appropriate balance between what you spend to prevent non-conformance against the cost of some non-conformances getting out to your customers and into the world. So that's really all this means. Where it comes to food and food safety, of course, the curve isn't quite a parabola like this. You know, the cost of non-conformance is so high that, you know, we spend virtually whatever it takes to avoid any type of external non-conformance. So think of the conformance side of the spending, the conformance side of the cost of quality model as insurance, right? This is cost avoidance. So we understand first and foremost the true costs of those internal and external failures, and then we invest appropriately in prevention and appraisal to mitigate that risk. Just what we showed you on the curve, right? Looking to optimize where those two curves cross so that you spend just the right amount based on the risk and based on the nature of the price of non-conformance. Now, one thing that you can do, not a lot of companies do this, but I would challenge you to look at your HACCP plan and look at what it costs, maybe on an annualized basis, right? What is the cost of your pest control, and what is the cost of all of your sanitation and all of your inspections and tests, et cetera? Add that up. And what does it cost, right? What's the cost of your HACCP? That now becomes your prevention, detection, sort of cost of conformance. It's not all of it, but it's most of it, and it's a fun exercise. Add that up, and that becomes your insurance premium, your annual insurance premium, right, against what we know would be much higher costs if we were to have failures in the field. So try that out as an exercise. I think you'll find it worthwhile. Now there is some good news. When we add up the cost of poor quality, the cost of non-conformance, right? We know that those costs come right off the bottom line, and we know that if we were to have some type of food safety recall in the field, or we have very demanding customers, we know that some of those costs can really be punishing and they can be crushing. So we spend whatever it takes. Now, once we understand the cost, the external cost of failure, we can now invest. We can use that as free money, as a bucket of free money to invest to bring that cost of external non-conformances down. So we think about the costs of remaking orders, the cost of expedite, either finished goods or raw materials, sorting, traveling to customers, containment costs, all of the other costs associated with failure. Add those up. That becomes a bucket of free money now from which we can draw to make investments. These investments will literally pay for themselves. So think about whether your investment in your planning and all of your preventions cost or pay. Is it worth it? Use that HACCP plan, use your control plan to drive down your cost of poor quality and meet those cost targets that you've set for your cost of conformance and your cost of non-conformance. Now, most people capture what I'll call the basics, right? Cost of customer complaints, cost of scrap, cost of rework. I want to talk a little bit about opportunity cost, and I want to encourage you to roll an opportunity cost factor into your cost of quality model. The definition of an opportunity cost is the loss of some potential gain from other alternatives other than the one that you chose, right? So what's the cost of, or what did I give up by choosing to do what I'm doing rather than something else? And I'll take you through an example. So when you're running your plant and you're making scrap or you're making rework, what else might you have been doing? Couldn't you have been making good product? How much extra profit could you have earned if you were building products to sell instead of products to throw away as scrap? And the cost of those goods that we throw away are not charged at the cost of the ingredients or the cost of the labor. They're charged at the full selling price. That's the opportunity that we lost. If I throw away a batch of product that cost me $1 to make, but I sell it for $5, when I scrap that batch, my cost of internal failures is not $1, it's $5. I lost the opportunity to sell that product for $5. Selling price, not just manufacturing cost. The cost of poor quality or high failure rates are the capacity killer. Now, if you're not busy, it doesn't matter, does it? If I'm not busy, I have lots of time, lots of labor to remake an order. This really starts to matter when your plant is full. The true cost and the impacts are different, right? They're masked by the fact that you have lots of free capacity. But when you're full, like I said, the true cost of every part you scrap is the selling price. You will never get that time back again. Rework, reruns, etc., they're done on overtime. So make sure you charge that accordingly. The other big problem is if you now are losing capacity to scrap and rework and reruns, your customers' orders back up and their lead times get longer. And I've worked with clients where they get stuck on this treadmill and they can't get off. So think about those true opportunity costs. What's the real impact on your business outside of just a few dollars worth of raw materials? You may have heard something like this before. I've heard companies say that scrap isn't a problem here because, you know, we make aluminum or cast iron or plastic and we just regrind it, we just melt it down, right? The material is reused. We lose almost nothing. Or you might hear a company say, we pay employees anyway. They're already being paid to work an 8-hour day, so they sort some parts for us, you know? It doesn't cost us anything. Be very, very careful. In a traditional cost of quality, a cost of poor quality model, you hear numbers like 5% of sales, maybe 10% of sales. When you factor in these opportunity costs and these true impacts to the organization, the true cost of non-conformance can be up to around sometimes 30%. It's not 5%. So my mission here today is to get you maybe thinking in a new way about capturing these opportunity costs. If you're full, scrap and rework and reruns, they kill you. Here's another kind of example. I play a little game on my phone. And when I play the game on my phone, there's a point where based on the level you are, there's a bonus round and you can spend $1 of your in-game currency to win these gems. So now when I get to this bonus round, I have a couple of choices. I can spend $1 and I can always get 3 gems. That's a guarantee. Or I can spend that same dollar and try to reach to win 4 gems. And I don't know the chance of success. Sometimes you win, sometimes you lose. If you win, you get 4. If you lose, you get nothing. So maybe it's a 50% success. Now I play it safe. I always spend $1 to get 3 gems rather than reaching for that extra gem, because every time I fail, I don't get 4 gems, I don't get 3, I get 0. So every time my 4-gem bet fails, remember the opportunity cost. I could have had 3. Instead of 3, I got 0. So now I have to play the game more. I have to now, if I choose to, I have to chase the 4-gem bet 3 more times just to break even. If you think about that, you'll see that that's true. So I can play it safe. I can choose to always get 3 instead of maybe getting 4 because of that opportunity cost. If I play 4 and I lose, I lost 3. I could have had 3. I've got to play the game 3 more times just to break even at the higher level. So think about that. And think of that in terms of profitability. You could have sold that product for some profit margin. Now you might have to sell, if your margin is 10%, you might have to sell up to 10 times more product just to break even for the selling price of that material you scrapped. That's the true cost of poor quality. Here's another example. This is from my own life. There's a cheap gas station 20 minutes away from my house. I can save about $6 a tank. Now that's a lot of money. You're filling up a tank of gasoline in your car. I can save $6 each time. Is that worth chasing? Well, my time, right? I'm earning $18 an hour getting cheap gas. Now, if I'm billable, I earn more than $18 an hour. So if I am giving up billable time to chase cheap gas, that doesn't pay. Now, of course, I go for my cheap gas because I get it on a Saturday or I get it at night, right? Obviously, I'm not working. If I'm not working, the opportunity cost for that hour is 0. I can't sell it. So earning $18 an hour going for cheap gas pays. If I'm billable and I could be selling that time to a client, $18 isn't a very good bet. Opportunity costs. Think about that. That's the key that most companies don't consider enough when considering their cost of poor quality. This is kind of a lean question, right? What is the value of a half-built house? You do this in your own organizations. Don't you take inventory every year? You take inventory. The accountants tell you that, you know, your half-made product has some value. No, it doesn't. A half-built house is worth nothing. It's worth less than the raw materials you put into it because now they've been consumed. You'd have to pay to tear down half a house. You cannot, like, goods and services have no value at all until you sell them. So the value of a half-built house is 0. Right, so like any type of project, identify those opportunities for cost reduction based on, and then quantify the true cost of those problems, and then based on what you see as needing attention, based on what those things cost, you can prioritize the improvement actions, then choose the actions to work on and manage that like a project. And then after you're done with your process improvement, evaluate. Evaluate your success, look at cost reduction as that success metric, and then lock in the gains, right? Sustain those gains and continuously improve. I'm not going to go through all the steps, but sometimes it's garbage in, garbage out. So spend enough time really understanding and recognizing what are those opportunities that are important to reduce the cost of poor quality. So we can do that through brainstorming, we can do it through Pareto charts, etc. And then you'll see on the slide on the right some example of how to prioritize, right, the effort to make the improvement on X versus the benefit in Y, or the impact, right? So you have these quadrants. So you obviously want to get at the low-hanging fruit where you can invest a little bit of effort, maybe a little bit of cost to get a high benefit, a high impact on reducing costs. So that upper left quadrant, right, is really where you want to be. And then, so prioritizing, right? Get at the best projects first, the ones that are going to give you the best bang for your buck, if you will. I want to take you through a couple of examples, and then we're going to be essentially done. So I thought by giving you illustrative examples from my own experience with my own clients, that this might be useful to help you frame your own cost of quality model. Well, this was a plastic extrusion job shop. They had many customers, some automotive, it doesn't matter, but they just had lots of customers, and they had some parts that they painted in-house. And they had customer rejections and internal reruns of about 3 or 4 per month. So not too bad. Certainly not a company in crisis. They had a rate of rework of their plastic molding defects and their paint defects of about 2.5%. Again, not a company in crisis. That's not an unusual level. I put this in here because I was working with them, and they had said that their current cost of poor quality was about $300 a month, or $3,600 a year. And I knew right away, without doing any mathematics, that had to be way low. So we took them through it, and we got the real number for them. Now, it's also important to know that their plant was at full capacity, and they had a customer backlog. So here's an example of how you would actually do this. So this is an example that we used with this company. It was one customer rerun. We had to remake an order because it didn't meet the customer's requirement. There were 720 pieces that they had to make. These were fairly large parts. So we made 3 parts per minute. They were large parts. It took about 4 hours to run 720 pieces. The machine charge out rate was $600 an hour, and you need to add an hour to set up the mold. Labor, 1.5 operators. Because they were full, they had to do it on the weekend, so we charged that labor a time and a half. $30 an hour, because whatever their charge out rate was, $18 or something times 1.5. The cost of additional inspection and packaging, we said it was about $250. The parts sell for $2.10. That was the selling price. The true cost of poor quality for one single run, 5 hours of machine time is $3,000. Labor, inspection, packaging, $180 plus $250. And then the cost of the lost sales, that opportunity cost, $1,440. So this one single run was $4,870, more than what they thought their cost of poor quality was for an entire year. If you look at my example, I hope that your eyes are popping out of your head. I hope that you're actually saying, that can't be right. But you know what? It kind of is right. And you know that's true. And that's the epiphany that most folks have when they start to see these numbers. Their first reaction is, this can't be right. The numbers are too high. But yeah, you know, it kind of is right. And that's the breakthrough, and that's the value of doing these calculations. So this one run cost $4,800, not including, you know, the cost of the supervision and the support. We didn't put that in. Administrative penalties imposed by the customer, that wasn't in there, right? We didn't talk about the staff time to manage the, you know, and reschedule and do all. This was just strictly manufacturing impact and selling price impact. It didn't include the cost of cutting into the already full schedule, except for just the weekend overtime premium. It didn't include any cost of customer annoyance. So just for fun, if you consider this was some typical run, $4,870 can be the average cost of a rerun. If we have 4 per month, 48 per year, $233,000 in cost of poor quality for this one company.
And they thought it was about 3K.
They thought it was, yeah, 3.5K.
So
like I said, as soon as I saw the number, I said, all right, get me a pencil. We're going to figure this out for you.
Well, it's funny because we've got just on the backside of this, Dennis, a lot of people all of a sudden just started asking, hey, can I get a copy of the presentation? I have a feeling they need to show this to some people.
It's the multiplier effect, right? I mean, one might cost you a couple of $1,000s, but then when you have 100 of these events in a year, boom, it's 200K, right? Here's another quick example, same concept. 5,000 orders per year, 2% rework, that's 100 rework events per year. Inspect and reject the original lot, $30. Make up the rework ticket, $45. Rework the product on a weekend, $360. Move some material back and forth, repackaging, reinspection. If you look at these numbers, they're not very high. That's only $730. But when you're doing 100 of them a year, it adds up awfully fast.
Yeah.
If you could reduce that by 50%, you'd be saving, $37,000. Huge, huge opportunities. And we're basically at the end of the presentation. How bad can it get? All I'm going to say about Takata is you heard about the seat belts. Takata was the world's largest automotive airbag manufacturer, right? The airbags would blow up and kill people. It led to 42 million cars recalled in the United States alone. The world's largest automotive airbag manufacturer went bankrupt. Its value went from 400 billion yen to 4 billion yen. It was picked up. Here's the worst cost of this debacle. Takata was a Japanese company. It was picked up for cents on the dollar by a Chinese competitor. What's the cost of that?
Yeah.
And we'll just leave it at that. Buy the book. It's not my book, but full disclosure, Doug Wood, the editor of this book, is a close personal friend. But it's a good book, available through ASQ if you want. And that really concludes the presentation. I'm sure we have some questions we want to get to. Thank you for your participation and for listening. So Aaron, why don't you hit us with some questions here, and I'm anxious to dive in.
Absolutely, yeah. So a lot of folks asking for the presentation material. We'll get those to you if you've asked for them. Thank you. Larry asked a really good question a little bit ago, and I think we answered it a little bit, but I'd love to just kind of go through it. So Larry works for a small privately owned company who owns 3 dairy plants in 3 different states. How do you convince the owners that tracking cost of quality is a good thing that should be done? I think this is a fantastic question because it speaks to how do you convince the owners to say that you focus on this? This is important.
Yeah, well, that question almost answers itself, because money is really the only language that executives and owners understand, right? So Larry, if you go back to your owners and you say, well, we're getting an awful lot of complaints and their customers aren't happy and this and that, you might be met with a shrug before he politely, shows you the door. But if you can express those problems in dollars, your owners are going to pay attention. So it's not really even about you convincing your owners that tracking this stuff matters. If you track it, now you have an opportunity to go to your boss or your owner and say, look what these things cost. And as soon as you can express them in dollars, you're going to get their attention. So the question is almost not how do you get owners to track this stuff? It's we track it, bring it to the ownership, and build a business case for some improvement, right? And say, hey, the cost of this problem that we have 100 times a year, it's costing us whatever, right? 100 grand.
Yeah.
Let's try to spend 20 or 30, right, to rein that in. Dollars are the only language that these folks understand. So by taking these quality problems and these quality concepts and expressing them using a scale of dollars, it really gets them listening.
Yeah.
Hope
And
that answers the question.
that's always true. Money talks, right? So
Absolutely.
Dennis, I'm backing up because Maurice is asking, when we're
Yeah.
going through one of the examples here, wouldn't you include raw material usage within this calculation as well? He asked it right here.
You can, but that also goes into the selling price, the $2.10 there in line 5.
Yeah.
So you could do that, right? I mean, you could decide how you're going to do that, but by building in a selling price, it does kind of include some raw material.
So
there's lots of different ways to kind of consider this, but my message would be, no matter how you sort of decide to parse this out, make sure you roll up that opportunity cost. That's where it starts to really cost you money. And if you're full, right? If you're at full capacity, it's eating your lunch.
Yeah. Good. All right, thanks for
Great.
that, Maurice. I've got Jared asking, where do you place, this is interesting, where do you place the cost of QMS software? He says, I think cost of conformance, but the appraisal, the time and labor, I'm kind of synthesizing this a bit for us, Dennis, so bear with me. But the time and the labor to do the check or do the appraisal, like the in-process check, it seems like it hits both sides of the equation, that QMS software.
Right. No, that's a great question. I would consider the cost of the software and maybe the annual licensing, et cetera, as a prevention cost on the conformance side. Mm-hmm. Then the use of the software, right, the hourly checks, they are the appraisal cost. So I'd probably split it up. So there's almost there's the cost of the software, almost the capital cost, if you will. I'd put that down as prevention. And then the use of it for ongoing inspection and tests, I'd say that's appraisal cost.
Right, because what we see very typically with our customers, Dennis, is going from more manual methods of these tests, pens, papers, you've got to go get the clipboard, you've got to, all of these costs, and it takes you more time to do the check, right? And so if you've got a tablet, you can do a check really quickly. We're seeing 80% time savings in using software instead of more manual methods. So that would be on that appraisal side, right?
Good, right, absolutely. So you take the labor associated with those inspections, and you say, now it costs me, I have an 80% reduction. So instead of $10,000 in inspection costs, it's costing me $2 million. That's exactly how you do that.
Got it. Cool. Another one, interestingly enough, sort of an organizational question, Dennis. Where does the reporting of COQ usually belong, right? We talked about it, it's kind of like, is that the CFO office? Is this the plant manager? Where do you typically see that in your client base?
Definitely engage your accounting people. Some of the stuff we're talking about here in terms of opportunity costs, it doesn't fit the GAAP accounting models, but when you describe it to them, they generally get it. And it's a good way to reality check your model. If the accountants can say, yeah, you know what, Dennis, this really is the cost, you've got it right. So use the accounting kind of infrastructure that you have. In terms of where you report it, you probably have monthly meetings already, right, where you review your key performance indicators. Safety and yield and productivity and so wherever you evaluate your key performance indicators, your cost of quality could and should be included with those. One other thing I didn't say in the presentation is the cost of quality, or the cost of poor quality, however you parse it out. It's a great aggregate metric, right? Because there's so much rolled up into that one single number. It's just a great way to track it as a barometer of the effectiveness of your operation.
Yeah, it really is. It's a critical factor in most cases. So We got one quick question. Somebody asked for an example of error proofing. What's it? Can you give an example of what error proofing is?
Error proofing, yes. I would try to find a food one. I can't think of a food one, but let's say I'm putting something together. I'm doing an assembly.
Mm-hmm.
Well, if I can install one of the parts backwards, that's an error, right? I have to put two pieces of something. Maybe I have to put a cap on a bottle. And if there's a way I can do that wrong, that's the error. So we try to error proof that failure mode. So for example, if I can assemble a part, say backwards, I want to design the part such that it only fits one way, and I literally can't assemble it wrong, right? To error proof. So instead of assembling the thing, say backwards, right, I've designed the two pieces that they only fit one way, so I can't screw it up. Error proofing.
Got it. Okay, that makes sense. Thanks, Dennis. And then we got time for just one last question. This is an interesting one because it kind of goes to the productivity side. Very astute. Jennifer asks, unplanned downtime due to equipment maintenance. All right. Should that be, where does that go? Is that in the equation for cost of quality? Unplanned downtime due to equipment maintenance, or is this not a quality issue?
Well, I'm going to say no, only because you probably, and I hope you already track that separately, right? In your key performance indicators, you should already be tracking downtime and unplanned downtime, breakdown, right? You should be tracking that already. Because you track it usually separately, it does not also go into the cost of poor quality, although it could. So I don't know if that's much of an answer. It's not typically in the model because you're typically already tracking it as a separate line item.
Got it. That brings us to the end. There's a couple of things coming up, more resources, of course, available at safetychain.com. Please use that email for Dennis. He'd love to hear from you. And then just so to your edification, Dennis, tons and tons of people saying great presentation, lots of thanks, and so well done. That's it, Dennis. Thank you so much for joining us, and it was a pleasure having you aboard Beyond Compliance.
Thank you for the invitation, and thanks everybody for your participation. If you have any other questions about this topic, please reach out. I'd love to talk to you.
Fantastic. All right. Well, that'll wrap it up for us today. Thanks, everyone. Go and make better products, less cost of quality. Cheers.